Hello guys, welcome back to my channel, and it has been a while since I have uploaded anything. And there is a good reason for that as well. I have just been really busy. I have been busy with my internships, and also I was busy learning new skills. I learned about context engineering, and most importantly, AI agents. I decided to learn about AI agents specifically because it's all the rage right now, and I thought learning this would allow me to build way more powerful apps for users. For example, I am thinking of building a app where if you can type, like basically an app for biotechnology students where you can type your requirements and it will generate a very scientifically backed diagram which you can use for your research. But right now I wanted to talk about something I built while I was learning AI agents, and I think one of the most important uses in our daily life, especially mine, is coding AI agents. So you know what, I to learn AI agents I just decided to build one. So now I'll show you the code of that AI agent I built. It's not really a production grade AI agents, and it's not really comparable to any of the good AI agents which we use in our IDEs, such as Claude AI agents, Cursor AI agents, not Claude, Cursor AI agents, Windsurf, etc. It's not really comparable to that, but you will get an idea of the basic building blocks of how they are built. So this is the main entry point of my coding assistant. It is a CLI tool just like Cloud Code, but it is obviously just a prototype and not at all comparable to the actual product such as Cloud Code. But here I have used the Google Gemini library to build it. I haven't used anything fancy such as LangChain to build this because I just wanted to show, and I also wanted to learn the basic principle of how all of these AI agent work. So let me just start going through the code and explain it to you. First of all, we are loading the client, Gemini client, by loading the environment keys. It's not that complicated if you know the basics of backend. But here is the main entry point. This is the main function where I have defined a argument which you can pass while calling it. You know what? Before I explain the code to you, I'll just like to run the code so you can see what is going on. Now I will show you a demo of what is actually going on when you run this AI agent. So this is how you run it by using run main.py, because main.py is the entry point of this project and this CLI tool. And I have asked it to give me the contents of the current directory, which is a very simple use case for a coding AI agent, and it should be able to do it. But now, disclaimer, you might be thinking that it gives me these files, but it won't, because I have wired it in such a way that it is only allowed to access this container, like this folder. And there is a reason for that, and I'll get into it later. But for now, you can just see that the AI agent is only allowed to look into these files. So this is for the AI agent. This is the main directory. So if I just run this, you will see that it will list all of the contents of this directory, which is the calculator directory. As you can see, it gave us a function call. It returned the result because it knows that this is my user prompt, how many tokens I have used, how many response tokens was used, and mainly it returned the answer. The current directory contains these files. As you can see, it actually contains these files: lorem.txt, readme.md, main.py, yeah, here, test.py, and package directory. Now that you have seen how the actual application or the AI agent works, now I'll go through the code and explain the flow to you. This is the main flow which you have to be concerned about. I'll go into the functions and why it only has the access to this calculator directory later. So here, first I am obviously creating it such that my CLI tool can receive arguments. It's not important. And I have created a message variable which stores all of the history when you run this AI agent CLI tool. Basically, it stores all of the steps which is performed by the AI agent and the user query. So it has a state and a history whenever you run it. This is the same principle which is used in chatbots. If you know how to build chatbots, it shouldn't be that complicated to you. But if you don't, just know that it is basically storing the history of the whole conversation that the AI agent is having. As I told you, I was using Gemini, and here we are actually generating the response. Here I have defined a config for it using the types library from obviously Google Gemini. You don't have to be concerned about the code, because even I forget the code. I just refer to the documentation like everybody else. I have passed a system prompt. Now this is very important in every AI agent application you build. System prompts. System prompts are so important that it can make or break your application. So it is highly advised that your system prompt should be as thorough and as descriptive as possible. Moving on, here I have given it available tools, which I'll get into later. So here, whenever a response is generated, I am appending it to the message array, like to store the history of the conversation. And then I am checking if there were any function calls. If there are no function call, we print the response and we exit. But if there were function calls, basically Gemini itself doesn't have the ability to call the function directly. What we have to do is it gives us the function name and the parameters. Like here, it gave me the function name and the parameters, and I have built a call function which calls other functions for me and returns the results of it. So here's the result. Now I have taken out the function response from the result, and then basically appended the function call result. So in the next iteration, it will be stored in the message array, and then the AI agent will have the access to the result of that function call. So as you can see, it's basically a very simple loop, and all AI agents under the hood work like this. Now before I move forward, I'll explain this function function, which I think is the most complicated part of the, no, not really the most complicated part, but it needs to be explained. So here in this file, which is totally related to just function calling, here I am getting all of my functions which I have written. I'll go into it later. And then I am creating a map for that function, that if I receive this name, map this name to this function, map this name to this function, etc. And you remember that available tools variable. Here is the available tools variable where I have given it the schema of all of the functions I have written. I'll go into the schema later, but first talk about call functions function. Here I am extracting the function name and extracting the arguments. If I don't receive any function name, error, simple as that. But if I do, I extract the function from the map I have created, and then one of the args I have given the working directory is calculator. I told you that I have limited the scope of this project to this calculator directory only, and this is how I did it. You will understand it more when I actually go into each of the function. Then I return the function result, like call the function, return the function result, and that is it. It's as simple as that. Now I will get into the main part of this project, which is the actual functions. As you can see from the imports, I have defined 4 functions for this prototype project, which is get file info, get file content, write file, and run Python files. So these are the functions which is actually doing the underlying processing of getting the file infos, getting the files, getting the file contents, writing into a file, and running the Python file. And all AI agents have, especially coding AI agents, have these tools. So let me go into one of them and explain the function, because explaining one function will get you the idea of all of the function, and because all of them are structured the same and have the same rules. So first of all, I am getting the base directory of the file, and basically defining a schema. This schema, as you can see, I was passing it to the LLM, tells the LLM that you have this tool and this is the arguments it takes. Here I have defined only the directory argument and not the working directory argument, but it takes 2 arguments. I have done this because, as you can remember, in the call function we were giving, like, setting the working directory ourselves by hard coding it to limit the scope of what the LLM can access. So here I have given a quick description of what this function is all about. Now this is the main part which you need to be concerned about. Other than that, rest is just the what do you call it, the process of it, which can be changed function to function. But here I am basically telling it, if the target directory is outside the scope of the permitted working directory, raise an error. If the file is not a directory, raise an error. And it is really important that you set these limitations in your functions, you hard code these limitations in your function, because it limits the AI agents and increases the security of the AI agent. Because if you don't set these limits in the AI agent, it will change any file in your, it has the ability to change any file in your directory or your computer, which can be really security breaching, for a lack of a better word. Yeah, and one more thing you might have noticed, I am returning a string. In the last, in the final process, in the final answer also, I am converting everything into a string and returning it as a string, because LLM are really good at processing string, and it is very convenient for LLM and efficient for LLM to receive the answer in strings. That's why I have done it. You can also go through the other three files, which is get file content, doing the same thing again, checking if the file path is not outside the working directory, and returning strings if there are any errors. And be you should be as descriptive as possible when just returning something, you're returning an error, so the LLM knows what went wrong exactly, so it can formulate an answer based on it. Same with the write file, right? Same with write file. Define the schema, checked if it is the working directory, like valid path, etc., and writing the content into it and returning that successfully wrote itna like successfully wrote into this file with this many characters, and this is the function to run the Python file, and it's that simple. I hope that I was able to convey all of these ideas in a coherent manner, and this was it. As you can see, building an AI agent is not that hard, and anyone with the ability to code can build it. So we are at the end of the video and the end of the project. First of all, I want to thank you if you watched this far, and thank you for listening to my rambling with my very broken English. And second of all, I hope that you understand the basic fundamentals of building an AI agent. It's Building an AI agent was one of the coolest things I have ever done, not as in a technical standpoint, but building it was so fun. And I hope that watching this video urge you to also build your AI agent and build way more cooler products with it. If you have any feedback or just want to connect with me, comment down below, and you can also visit my YouTube page if you want. And that is it for me, and I am signing out.